Okay, welcome everyone. Let's take a look at a chick weight data set that we're going to use to motivate our study of the apply function. So we've taken a look at a number of apply functions, and now I want to think about why are they useful in statistics, for example? What are they good at implementing? And so we need some data to illustrate that point. The data set that we'll work with is the chick weights data set. I'm just choosing this because it's built into R, which is nice. We don't need to install any package. It has one numeric variable and one factor variable, which is going to be great at illustrating how some of these functions work. So if you're curious about this data set, you can run question mark chick weights. You can run a summary to get a numeric summary of the two variables. So one variable is weight, and this is giving the weight of each chick in the data frame 6 weeks after they were born in grams. And then we also have a feed variable, which is a factor variable. So what they did is they had new hatched chickens. This data set contains a total of 71 observations of 71 chicks. And then they randomly split the chickens into different feed groups. They fed the chickens different types of food and then compared the weights of these chickens 6 weeks later to see if there was some association between the type of food that they ate and their weight. So we can see those summary statistics in this output. So before we do anything with the apply functions, you might not know what questions to ask. So that's where the exploratory data analysis comes in handy. So this question is saying, let's take this chicken weight data frame and create some plots from it to maybe illustrate some of the variables and possibly look for associations between variables. In this case, we just have two. So this is asking us to create a display of the weight variable in a density plot, then display the feed variable in a bar plot, and then we're going to compare the weights and the feed variables using side-by-side box plots. Okay, so we'll use the ggplot package. I've already loaded the core tidyverse packages way at the start of this notebook, but if you haven't done that, you'll at least want to load the ggplot2 package. And the data set that we are working with is chick weights. We'll indicate what our aesthetic mapping is. We want to create a density plot of weights. So I'm going to map the variable weight to the x-axis. I can choose some additional formatting if I want, but then I want to add my geom. And for a bar plot, we add a geom, or excuse me, we're doing a density plot first. For a density plot, it's geom density. I spelled that wrong, G-E-O-M underscore density. There's our density plot for chick weights. And you can see the distribution here, maybe roughly, I don't know, it kind of is normal distribution, but it's not really following any nice discernible distribution that I can see. Next, let's go ahead and create a bar plot of feed. So again, I'll use ggplot here. We have the same data set. And now the aesthetic mapping is we're going to map feed to the x-axis. And the geom that we'll add is bar plot. And I'll choose fill. I'll choose my favorite color, steel blue. And there's our bar plot. And we can see that these 71 chickens were randomly assigned to different feed groups. And each of the feed groups is roughly the same size, though not exactly. So now we can think about, well, is there any association between the type of food that the chicken received and their weight at 6 weeks? So here I'm going to, again, use ggplot package. We have the chick weights, and the aesthetic mapping that we'll choose here is we want to create side-by-side box plots. So that's going to require us to map two variables. And I'll choose to map X to the feed variable, or feed to the X variable. I'm going to map weight to the Y aesthetic. And then we want to fill in the box plots in a different color based on the feed group, let's say, just to give it a little extra pop of color. And in addition to that, we need to add a geom, and the geom for box plot is box plot. This is going to also add a label, a legend, excuse me, and I don't want the legend because we're going to know the feed group. It's going to be labeled on the x-axis as we've indicated. So I'm going to turn the legend off since it won't tell us any additional information. And I think this should work for us. And now we've got a box plot of the chick weights at 6 weeks based on the type of food that they received. And we can see here that horse bean, this must have like the least amount of calories. These were the lowest weight of all of the feed groups. And this casein and sunflower, these were the feed groups that seemed to have associated with higher weights overall. So now this can kind of raise some questions, and we can kind of dig deeper in analysis to see whether these differences are significant or not. But in the next video, we'll think about how we can use the apply functions to set up a bootstrap distribution to estimate the mean weight of all chicks at 6 weeks.